Okay, now we define change in potential energy as being equal and opposite to the work done by the conservative force, right? Okay. So the work done by the conservative force is equal to the negative change in potential energy. Okay? Now the net force is a sum of conservative and non-conservative forces. Okay? And that equals the change in kinetic energy. Because the work done by the net force is a change in kinetic energy. The net force has conservative and non-conservative components, as, for example, in a real spring. Now, the mix of those forces is somewhat complicated. Okay? It's hard to really separate them out and see which is which in a real force, but you can still accept that there will be work done by the conservative components of a force and the non-conservative components of the net force. Okay? Well, what's that mean? That means the work done by the non-conservative forces is equal to what? The change in the kinetic energy minus the work done by the conservative force, or conservative component, conservative forces, right? Make sense? And, of course, what's this? It's equal and opposite to the change in potential energy, right? So the work done by non-conservative forces is change in kinetic plus change in potential energy. Now, what are the implications? If I toss this upward and catch it at the same point, what forces other than gravity were acting on this thing?
Air resistance?
Pretty much just the air resistance. Was it moving very fast? There wasn't much air resistance. Okay, and it has a fairly high mass to surface area ratio, meaning that the work done by the non-conservative force really is pretty small compared to the change, say, in the potential energy. Conservative forces are much less than the gravitational force. The non-conservative, the air resistance, non-conservative forces are much less than the gravitational forces that act on it, okay? So that we can pretty much say that the non-conservative forces are negligible, which means that in this situation, the kinetic and potential energies have equal and opposite changes, right? Well, isn't that what happened? When I tossed it, it had kinetic energy. Potential energy increased until it sucked out all the potential energy. It didn't really suck out anything. You get the idea, okay? Well, then gravity pulls it back down and potential energy decreases, kinetic energy goes back to where it was, less what little bit was done by non-conservative forces. Okay? Make sense?